Welcome to the lecture number 27, dear students. From today I am going to begin very important chapter called as trigonometry. This is so important that the students who wish to do their career in engineering, or you can say any other field except medicine, trigonometry is useful. Whatever trigonometry we are going to study this year, this you can call it as only ABC of your future trigonometry. So from that point of view, this chapter is very important. Those who wish to do career in all the fields related to mathematics. So from that point of view, I would like to tell you, please remember one thing: whatever I'll teach you on one day, please revise it properly. It is very important to know all these formulas as well as this value table, these ratios of complementary angles also. In case if you don't know, then tomorrow when I start solving the problems based on this, you will surely not understand anything. And at once, if your base remains weak of this trigonometry, this is going to harm you forever. So remember that please do this trigonometry seriously and sincerely. The very great man S.L. Loney, it's not Loney, it's S.L. Loney. He has published two books, volume 1 and volume 2. Those who are very interested in trigonometry, because you will find your 11th standard 75% book is based only on trigonometry. So S.L. Loney has written two books. One is volume 1 and volume 2. Volume 2 is quite difficult, you may not be able to solve it. But volume 1 is very important. Those who want to make their foundation of 11th and 12th standard very strong, I would like to advise them, please purchase the book of S.L. Loney, volume 1 and 2. If you will be able to solve volume 2, I would say it would be a great achievement. So, here I have explained you the importance of this trigonometry. Now this name itself suggests you trigonometry. This is a geometry related to three angles. It's called as trigonometry. This year you are going to study the trigonometry applicable only to the right angle triangle. But from next year you will be studying the trigonometry applicable to all angles. Here you will find hardly 10 to 20 formulas are there, but you will surprise to know you have to remember minimum I am saying minimum 100 to 150 or even 200 formulas in 11th standard. And if you will not remember this, you can imagine how you will be able to do that. So from that point of view, this is a very important chapter. India's contribution to the trigonometry is also remarkable, because you will find Aryabhatta used the formula of sine ratio for astronomy, for study of astronomy. So from that point of view also you will find he is the first scientist in the world who used the trigonometry sine ratio for astronomy to study the astronomy. So here I narrate all the things which were related to this trigonometry. Here even you will find in last exercise we are going to study some problems also, or we can say word problems also. In that case also you will come to know the importance of this chapter. Anyway, now enough I said about this trigonometry. As I explained you, dear students, trigonometry is applicable to the right angle triangle only. That is what we are going to study this year. Then you will find, if I take triangle ABC, if I label this angle C as theta, then you will find angle B is already 90. So these two becomes complementary angles. So if this is theta, this will become 90 minus theta. Next to that you will find, if I am going to study all these ratios everywhere, you will find for theta, then naturally you will find for angle theta, this is opposite side. This is opposite side. Opposite means the things which are facing to each other. They are called as opposite. Adjacent side. Adjacent means you will find attached to one. They are called as adjacent side. So for this angle theta, AB is opposite side while BC is adjacent side. And since you all know, side opposite to 90 degree is always labeled as hypotenuse. So first formula to remember, sin theta. Please pronounce it properly. It's not sin theta, it's sine, S-I-N-E. So sin theta is equal to opposite side upon hypotenuse. So opposite side to theta is AB and hypotenuse is AC. So you will find that sin theta is equal to opposite side upon hypotenuse AB upon AC. In the same manner, cos theta. Cos theta formula is adjacent side upon hypotenuse. To this angle theta, BC is called as adjacent side. As I explained, this is an angle, so this is called as adjacent side. So adjacent side is BC, while hypotenuse is AC. So you'll find adjacent upon hypotenuse, that is BC upon AC. Next to that is tan theta. Tan theta formula is opposite side upon adjacent side. So you'll find here, as I labeled, AB as opposite side, BC as adjacent side. So you'll find AB upon BC. So these three are basic ratios. And next to that is cosec theta. But cosec theta is reciprocal of sin theta. Or vice versa. You may say sin theta is also reciprocal of cosec theta. It is one and the same. So you will find cosec theta is equal to 1 upon sin theta. Sin theta is opposite side upon hypotenuse. Therefore, cosec theta is equal to hypotenuse upon opposite side. So you will get AC upon AB. Here you got AB upon AC. Here you will get reciprocal of that is AC upon AB. Now come to the next one. Since these cosec theta, sin theta are reciprocals of each other, you will get product of cosec theta and sin theta is always 1. Now next to that is sec theta. Sec theta is a reciprocal of cos theta. Therefore, reciprocal of cos theta is hypotenuse upon adjacent. Okay? Because since you all know, cos theta is adjacent upon hypotenuse, while sec theta is hypotenuse upon adjacent. So that gives you BC upon AC. There you will get AC upon BC. Next to that is, again you will find same way, sec theta into cos theta is equal to 1, since they are reciprocals of each other. The product is always 1. Next to that is cot theta. Cot theta is a reciprocal of tan theta. Tan theta is opposite upon adjacent. Tan theta is opposite upon adjacent. Now you will get cot theta is adjacent upon opposite. Reciprocal of tan theta is cot theta. Cot theta is adjacent upon opposite. You will find here formula for tan theta, AB upon BC, and you will get reciprocal of AB upon BC is BC upon AB. Again same way, tan theta into cot theta. Since they are reciprocals of each other, you will get product of tan theta into cot theta is 1. So this is how you will find these 6 ratios are very important ratios: sine, cos, tan, cosec, sec and cot. Next to that, ratios of complementary angles. Now please try to understand. If this is theta, you will get this is 90 minus theta. Now if I say sine 90 minus theta, try to understand what I am saying. Sine 90 minus theta, opposite side upon hypotenuse. For this angle, 90 minus theta, opposite side upon hypotenuse. So for 90 minus theta, opposite side is BC. BC upon AC. But what is BC upon AC? BC upon AC is cos theta. Therefore, you will find sine 90 minus theta is cos theta. In the same manner, cos 90 minus theta. Now, cos 90 minus theta is adjacent side upon hypotenuse. Cos 90 minus theta, adjacent side upon hypotenuse, AB upon AC. AB upon AC. But what is AB upon AC? AB upon AC is sin theta. So you will get cos 90 minus theta is equal to sin theta. Tan 90 minus theta. Now tan 90 minus. For 90 minus theta, opposite side is BC and adjacent side is AB. So BC upon AB. BC upon AB, you will find it as, try to understand, tan 90 minus theta. BC upon AB is constant. So this is how tan 90 minus theta is cot theta. Next to that is cosec 90 minus theta. Now cosec 90 minus theta, this is 90 minus theta, correct? Now cosec is what? Hypotenuse upon opposite side. So for 90 minus theta, this is opposite side. So AC upon BC. AC upon BC. Okay? AC upon BC is sec theta. Therefore, cosec 90 minus theta is sec theta. Now, sec 90 minus theta. Sec 90 minus theta. For sec 90 minus theta, adjacent side upon hypotenuse. AB upon AC. AB upon AC. Okay. Just find out where AB upon AC, that is sin theta. So, cosec is over. Sec 90 minus theta. Try to understand. Again, I am repeating. Sec 90 minus theta. Sec is adjacent AB. Sec is adjacent upon hypotenuse. So you will get here somewhere AC upon AB, that is cosec theta. So sec 90 minus theta is cosec theta. Cot 90 minus theta. Cot 90 minus theta. Cot is what? Formula is for cot is adjacent upon opposite. Adjacent upon opposite. AB upon BC. AB upon BC. Is that when AB upon BC is tan theta? So you will find that cot 90 minus theta is tan theta. So this is how, dear students, you will find that these are also very important formulas which are called as ratios of complementary angles. So please try to understand. Here also cosec 90 minus theta is sec theta and sec 90 minus theta is cosec theta. Now very often we have to use the values of these angles right from 0 to 90. 0 to 90. So here I have written all trigonometric ratios: sine, cos, tan, cosec, sec, cot, and here angle theta. Now if I begin from 0 to 90, okay, if I begin from 0, 30, 45, 60 and 90, then you have to remember this way, first thing, that sine 0, 0 and sine 91. At least you can learn this very easily. Sine 0, 0, sine 91. Now you have studied 30, 60, 90 theorem. For 30, 60, 90 theorem, you will find that side opposite to 30 is half the hypotenuse. Side opposite to 45 is 1 upon root 2, the hypotenuse. Side opposite to 60 is root 3 by 2, hypotenuse. The same way. To remember this, sine 30 is half. 30, 60, 90 times. Sine 45, 1 upon root 2. Sine 60, root 3 by 2. So this is how you will finish your first row very easily. If you remember sine 0, 0, sine 91, then 30, 60, 90 and 45, 45, 90 triangle. So side opposite to 30 is half, side opposite to 45 is 1 upon root 2, 60 is root 3 by 2. Now whatever the values you have written in the first row, simply write them in a reverse manner. 1 comes over here, root 3 by 2 comes over here, 1 upon root 2 at the same position, half will come over here and 0 you have to write in the last column. So this is how you will find cos 0, 1, cos 30 root 3 by 2, cos 45 1 upon root 2, cos 60 half and cos 90 is 0. Now tan. For getting this one, it is very easy. Why I am telling you? You all know the very important formula that tan theta is equal to sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. Remember these very important formulas. So if you can say, if you will write here that value of cosec theta, okay, cosec theta. Cosec theta is 1 upon sin theta. Try to understand. Cosec theta is 1 upon sin theta. So 1 upon sin theta, 1 upon 0 is what? Not defined. Any number upon 0 is always not defined. So this is how we will find cosec theta is not defined. Next to that, cosec theta is reciprocal of sin theta. Reciprocal of 1 upon 2 is 2. Reciprocal of 45 is 1 upon root 2. Reciprocal of it is root 2 upon 1. Next to that, reciprocal of sin 60 root 3 upon 2. It will become 2 upon 2. Next to that, cosec theta. Reciprocal of 1 is 1. So this is how we will get the values of all cosec thetas, reciprocal of sin theta. Now, next to that is sec theta. Sec theta is reciprocal of what? Cos theta. Now, whatever values of cos theta, you have to simply take the reciprocal of it. Reciprocal of 1 is 1. Reciprocal of 3 upon 2 is 2 upon root 2. Reciprocal of 1 upon root 2 is root 2. Reciprocal of 1 upon 2 is 2. And reciprocal of cos theta, sec theta. Sec theta is 1 upon cos theta. Sec theta is 1 upon cos theta. 1 upon 0 will be not defined. Sec 90 is not defined. Now cot theta. Cot theta is reciprocal of tan theta. 1 upon tan theta is cot theta. So 1 upon 0, not defined. Reciprocal of 1 upon root 3 is root 3. Reciprocal of 1 is 1. Reciprocal of root 3 means root 3 upon 1. Root 3 means root 3 upon 1. That will become 1 upon root 3. And next to that, the last value, right? Here you may write cot theta, okay, is reciprocal of not defined as 0. So this is how you will find that these values are there, here trigonometric ratios are there, angles are there, and you have to remember all these. So please write this as well as not only to write this, but learn this. I would say learn this. Minimum 10 to 15 times you write this again and again. Then only you will be able to solve the questions from exercises. Now there are 3 very important identities are there. I am going to explain you that these 3 identities. Even I will give you the proof of these 3 identities, and then I will stop. So look here, dear students, we have studied very important things. Now I am going to explain you very important identities are there. Important identities. So these are important identities. So here you can keep this as it is. Yes. Only I don't require this 90 minus 3. Okay. Now you will find, even since I have explained you all this, I am going to note this. 3 identities are there. If you will understand these 3 identities, we have to use in sums also many times. Okay. Now see here, dear students. Identity 1, sin square theta plus cos square theta is equal to 1. We have to prove sin square theta plus cos square theta is equal to 1. Very important identity. Okay. Now see here. Sin theta is what? Opposite side upon hypotenuse. Correct? So AB upon AC. AB upon AC whole square plus cos square theta. Cos is what? Adjacent upon hypotenuse. So BC upon AC. Okay, this is LHS. I am going to do sin square theta plus cos square theta is equal to 1. LHS is equal to RHS. If I square this, I will get it as AB square upon AC square plus BC square upon AC square. Since you all know, if denominators are same, we add the numerators. So I'll get it as AB square plus BC square upon AC square. Right? Now, in triangle ABC. In triangle ABC. By theorem of Pythagoras. By theorem of Pythagoras. You all know theorem of Pythagoras that AC square is equal to BC square plus AB square. Correct? So hypotenuse square is equal to one side square plus other side square. So AC square is equal to BC square plus AB square. Please note here, I obtain here AB square plus BC square. AB square plus BC square. I can substitute as AC square. So AC square gets cancelled and I got it as 1. So my first identity, sine square theta plus cos square theta is equal to 1. Now, same identity, remember, while solving sums, I use the same identity in different way. I can write the same identities in two different ways. Sine square theta is equal to 1 minus cos square. If I transfer cos square theta on right hand side, sin square theta is equal to 1 minus cos square. In the same manner, cos square theta is equal to 1 minus sin square. So one identity only, that is sin square theta plus cos square theta is equal to 1. I can write it as sin square theta 1 minus cos square theta. Cos square theta is equal to 1 minus sin square. So this is how you will find. I give you the proof also of this first identity. Now the second identity. Second identity is 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. Here also you will find same thing. I'll take here triangle ABC. Angle B is 90. C is theta. A, this is hypotenuse, and this is adjacent side. Y, you will find AB is opposite side. Same figure. I have taken the same figure. Now please see here. 1 plus tan square theta. Fine. LHS is equal to 1 plus tan square theta. Tan theta is equal to tan theta. What is tan theta? Opposite side upon adjacent side. Opposite side upon adjacent side. So AB upon BC. AB upon BC. Therefore, tan square theta is equal to AB square upon BC square. Okay. In this identity, I have to get sec square theta also. Right? So sec theta. What is sec theta? Hypotenuse upon adjacent side. Hypotenuse is AC upon adjacent side is BC. Therefore, sec square theta is equal to AC square upon BC. These two are very important values. Because I am going to use now in 1 plus tan square theta is equal to sec square theta. That is what I have to prove. Now 1 plus tan square theta, 1 plus tan square theta, that is LHS. 1 as it is plus tan square theta. What is tan square theta? AB square upon BC square. AB square upon BC square. 1 means 1 upon 1. Cross multiplication BC square plus AB square upon BC square. BC square. Now you will find by theorem of Pythagoras. Please remember, dear students, AB square plus BC square, AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. Theorem of Pythagoras. AB square plus BC square is equal to AC square. Now I am going to substitute for AB square plus BC square is equal to AC square. So AC square upon BC square, but what is AC square upon BC square is sec square. So you will find finally sec square. See here, sec square. So you will find 1 plus tan square theta, 1 plus tan square is equal to sec square. This is our basic identity, correct? Now you will find we can use the same identity, right? How we can use? 1 is equal to sec square theta, right? 1 is equal to sec square theta minus tan square. Try to understand. 1 is equal to sec square theta minus tan square, or tan square theta is equal to tan square theta is equal to sec. So second identity also I can use in a 3 different way. Our basic identity is 1 plus tan square theta is sec square theta. Same way we can write 1 is equal to sec square theta minus tan square theta, or tan square theta is equal to sec square theta minus 1. So this is our second identity. Now third identity is also there. These 3 identities are very important. And 3 identities. The third one, I'll use the same figure. Third identity is, find 1 second please. Third identity is 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to cosec square. Third one, 1 plus cot square theta is equal to cosec square. Third identity, very important. These 3 identities we have to use very often while solving science. So 1 plus cot square theta is cosec square. Like in this identity only, I am going to find out the values of cot square theta, cosec square. Cot theta is equal to, cot is reciprocal of tan, and formula is adjacent side upon opposite side. For cot, adjacent upon opposite, BC upon A, BC upon A. We need cot square theta, okay? So cot square theta is equal to BC square upon AB square. Cot square theta, I got it. Now you will find, we also have to find out cosec square theta. Cosec theta. Cosec is reciprocal of sine. So reciprocal of sine is hypotenuse upon opposite. What is hypotenuse? AC. What is opposite? AB. So cosec square theta here, cosec square theta is equal to AC square upon AB square. Fine. Now I am going to prove LHS is equal to RHS. So LHS is equal to 1 plus cot square theta. 1 plus cot square theta. That is equal to 1 plus cot square theta. I know the value. BC square upon AB square. BC square upon AB square. 1 upon 1. If you simplify this, AB square plus BC square, AB square plus BC square upon AB square. Correct? AB square 1 to BC square, BC square upon AB square. Now you will get 1 plus cot square theta. In the continuation you will get AB square plus BC square. Same way, AB square plus BC square by theorem of Pythagoras it is AC square. So I will write here AB square plus BC square is equal to AC square. It is understood by theorem of Pythagoras. So LHS is 1 plus cot square theta, AB square plus BC square. Now I am going to write it as AC square. So 1 plus cot square theta is equal to, right? AB square plus BC square, that is equal to AC square upon denominator is AB square only. Fine. But what is AC square upon AB square? See here, dear students. Cosec square theta is AC square upon AB square. Correct? So 1 plus cot square theta is equal to cosec square theta. So here you will find I have proved one of the very important and third identity also. 1 plus cot square theta is equal to cosec square theta. So 1 plus cot square theta is cosec square theta. Likewise, this also you can use in 3 different forms. 1 is equal to cosec square theta. 1 is equal to cosec square theta minus cot square. Or cot square theta is equal to cosec square theta minus 1. If I transfer this 1. Here also you will find, dear students, we can use same identity in 3 different forms. So these 3 identities are very important. That is sin square theta plus cos square theta is 1. Same way you can say cos square theta is 1 minus sin square. Sin square theta is 1 minus cos square. Second identity, 1 plus tan square theta sec square. Same way you can say 1 is equal to sec square theta minus tan square theta, or tan square theta is equal to sec square theta minus 1. As well as 1 plus cot square theta is equal to cosec square theta, you can say 1 is equal to cosec square theta minus cot square theta. Cot square theta is equal to cosec square theta minus 1. I have already explained to you, as well as I have already cautious you about the importance of this lesson. So hope for the next lecture, when we'll begin that time, or lecture number 28, I'm sure that you will come prepared, or you will keep yourself prepared by learning the table, formulas and these identities. So that's all for today. So please see, dear students, very important chapter is trigonometry.